Hi Josh, let's do this 4 problems in geometry.
Yes.
Number 1, a point E is chosen on AB and through E. A perpendicular segment C. Can you write that perpendicular segment? Is drawn. If AA is equal to 4, BE is equal to 12 units, and C is 6 units, find the radius of the circle passing through A, B, and C. And how far is E from the center?
Yes. So first, we have to analyze the situation. We have a chord AB, and then there's a perpendicular segment from the chord to the circle. So if we move E a little here, I mean, where will I put E here? And
Okay.
then I will draw a line. Wait. I'll just extend it. Yes.
Okay.
There.
Calculate
From E to the circle. Then we will have a point. We will name it D.
intersection uh, where the segment you drew touches the circle.
Yes. So this will be D. Okay, so now I will invoke the intersecting chords theorem. It states that when there are chords that intersect, then the this let's say for one chord AB, the segments formed by the other chord. So if you cut one chord, the segments that it produced, AE times EB. This is B cut by E, but cut by CD is equal to the product of
Yeah.
AE and EB is
The
equal
segments are
to,
the products.
yeah,
The product of their segments are equal.
CE times ED. This is CD cut by AB. So AE 4 times 12 equals CE 6 times ED. So therefore ED is 48 over 6 equals ED equals 8. So ED or DE is equal to 8.
So clear 8 on the figure.
8.
8, yes.
So now, find the radius of the center passing through A, B, and C. So first, to find the center,
Will it be
wait,
below
actually,
or above?
to find the radius, we of course need the center. We can't,
Yes.
we don't have any other way to do it.
So is the center on the left side or right side of C?
Yes, we will.
Obviously, it is only on the based on our figure. It is on the
Yes.
right
So
side.
actually, maybe,
About if
but
it's it will
if we can't trust the figure,
yes
12 is greater than 4, so 12 must contain the center while 4 does not. Or at least
okay
the line does.
yes
Because 12 is obviously bigger than 4, it must be the CD is shifted so far to the left. The center must be on the right.
yes
So we
so
are going to approximately triangulate where the center is. So since 8 is greater than 6, then AB must be higher than the center. Otherwise, if there's another chord, there's another theorem. I forgot the name of the theorem. It goes like this. There is a circle, and then there's a chord. I don't know. There's the diameter. So in this diameter, there's of course the center is in the middle, so the midpoint. If there is another chord, if there's a chord that intersects with the diameter, these two segments are equal. So if let's say AB was the diameter, it's quite obvious it's not. But if it were the diameter, then 6 should CE should be equal to ED. So 6
Yeah,
should be
the
equal
two
to 8.
segments on both sides.
But it's not. So
Yes.
8 is greater than 6, so the center is below. Similarly for AB. So the by eyeballing the center should be approximately there. Let's name this
Or a little
center.
more to the left.
Yeah, maybe. Huh?
Little to
Yes.
the left.
I think
Yes.
so. Yes. Oops. Ah. So thankfully there is a redo option or an
So
undo
I can reduce
option.
red for that segment.
Okay. Which segment? Ah, yes. Okay, so let's call this center P. So this center P is below AB and to the left of CE. So like Cartesian coordinates, we are going to find the radius. So so first we will in Cartesian coordinates we will triangulate the location of B in terms of A and B, A, B and C, D. So if like I was saying in this figure where I pointed out that if a diameter is intersecting a chord, the chord is bisected, and in fact it's actually perpendicular bisected, I think, but I don't want to claim something I don't know.
Yes,
Ah
perpendicular
yes,
by
okay,
bisected.
perpendicular bisected, good. So this is perpendicular. So if we draw a diameter, wait, I'll just get this one. Then make it here. It passes through the center P. So this must be a diameter. The only chord that passes through the center is a diameter. So this diameter P to in the parallel to AB, it should bisect CD. So this 6 plus 8. Wait, I will just put it here. 6. Wait, no. CE CE plus EB over 2 equals
What's that?
6 plus
What's
8
this one?
over 2
Hmm?
equals 7. E.
E plus ED?
Yes.
What's E?
CE plus ED.
Ah, CE. Okay, I thought it's
Parenthesis.
yeah.
Okay, funny.
Like
The D and the C. I get it. Okay.
seven,
So
yes.
7. So where's the brackets? So this will be 7. This will be 7. So it might be obvious, but then I'll just point it out. Give me another color.
Or can you put this
Uh,
one here on the other
the
side?
other side. Okay.
Yeah.
C. And then I'll just contract it here. Nice. So there's a cool way of flipping objects. Oops, like that. Here. Oh, I flipped the 7. 7. And then this will be and then the longer. Yes. 7. Okay, so it might be obvious, but 7 is 1 greater than 6, and then 8. 7 is also 1 less than 8. So this segment is 1. So in relation to AB, P is one unit down.
Below.
And then
One
similarly,
unit below.
yes, similarly for CD, I will draw use a different color. Maybe green, so it will be contrasting. I'm sorry, color blind people. Uh, P there. P and then up. There. Okay, so that looks approximately like another diameter.
So that's
So
perpendicular.
this is also
Perpendicular to the
perpendicular to the other one.
to the diameter.
Yes, this is parallel to CD.
Yes.
So this diameter should bisect AB. So 4 plus 12. 4 plus 12, I know. I meant the like the other one. AE plus EB. 2 equals 4 plus 12 over 2 equals 8. So this is 8 and that is 8. I will point this out. This is 8. Maybe it will get a little crowded. But, okay. So this, that, maybe we should start naming. Nah, I don't think it's necessary at this point. So 12 is 8 is 4 less than 12 and 8 is 4 more than 4. So this segment over here, another color. Something that will stand out. Yes, this one. Brown. This is 4. But finally there's color coding. If there was not any color coding, it would be hard to represent. So the center is 1 unit below AB, parallel,
So
using a
how
parallel
far
segment,
is
and it is also
how far is E
4 units to the
from
right.
E from the center?
Yes. So if E is for, like in Cartesian coordinates again, E is like, if P were the origin, and then P would be negative 4 1. So using the Pythagorean theorem, where is it? I will use the same colors as before. Uh, no, not necessarily.
Just draw a rough figure.
So
So
this
how far?
should be perpendicular. I will. Wait. That was technically not the. So since P name this F, just for me to use it. Since PF is parallel to CD, then and CE is parallel to PG. Okay. So since AB is parallel to PG, CEB, angle CEB, which is a right angle, so this must be also a right angle. Uh, Corresponding and then uh, adjacent, yes. So since those are rectangle, what? Yes. So since this is a rectangle now, we can draw one here and then four.
That's a center P and
E.
so you're computing for the distance of P from
Okay.
your center P.
So this is a right triangle, so PP.
What's PT?
Pythagorean theorem.
Yes, you state it for those who are trying to learn. Don't let's not assume that they know everything.
So this is the distance from E to the center. So now for the radius, the closest, we can use AB or C, AB, C or D, maybe even F or G if it's possible. But in this case, I will just use P to B. I can keep that, to get too crowded. So earlier we found that segment from PG to AB was 1. This is 1. E. So this was 8. It was listed here. So 1, 8. Then this is right. So again, PT. Square root of 1 squared plus 8 squared is equal to 1 plus 64 squared to 65. So PB is the radius. It's PB. So the distance from E to the center P is square root of 17 units. And the radius PB is square root of 65 units. Yes. Mm,
Okay. So, number 3.
base of an isosceles right triangle
The
is
base
50
of an
inches.
isosceles right triangle is 50 inches. Find its area. And
So, an isosceles right triangle is also a 45, 45, 90 triangle. Let this be 1 or 1. Maybe we'll use x as a variable. By PT, square root of x squared plus x squared, or square root of 2x squared, is equal to x squared of 2. So therefore, this is x squared of 2. So those are the dimensions of
so
the
that is
45,
what you
45, 90 triangle.
call isosceles right angle theorem.
Ah, okay.
In an isosceles right triangle, the length of the hypotenuse is equal to the product of the length of the leg and square root of 2.
Yes.
Yes.
So I will be using that now. So 50 inches in the oops. Okay. So here in this case 50 inches. 50 inches is equal to x squared of 2. So 50 x squared of 2. X is equal to 50 over square root of 2, or 50 square root of 2 over 2, 25 square root of 2. So x is equal to the square root of 2. So first, mm, we now know this to be 25 square root of 2. The area of any triangle is 1 half base times height.
So yes. So what did you do with the triangle there?
I just rotated it so it
I
will be
repeated
easier to
B.
see
We
which is
can
height and which is
let me put the parentheses open.
no. The parenthesis is to signify that those are
Okay.
not variables. So
And the H.
in this case the base is 25 square root of 2 is congruent to the height, which is also 25 square root of 2. So area
XYZ.
area XYZ. Okay. So this is 1 half 25 square root of 2. 25 square root of 2. This is equal to
XYZ. Okay, XYZ.
which one?
Yeah. Area of XYZ. So
25 squared times square root of 2 squared. So since square root of 2 squared is 2, and then this is 1/2, we can cancel this. So therefore this is 25 squared, which is 625
Square inches.
square inches. Ah wait, it was said in the problem inches, so square inches.
That's your answer.
Oops, wait. I just move this up.
Yes. So, or off.
Or
More direct.
hmm. Ah yes. So here, wait lang.
You can use a different color.
Maybe green
Just red or red.
or red.
Put the lines to separate.
So if you some people they memorize this, including me, the 45 45 90 triangle, which is of course the right isosceles,
Those are the
has
proportions of the length.
proportions. Leg leg square root of 2 leg is the hypotenuse. Yes. So x y z. So therefore x z equals xy is equal to zy over square root of 2. So therefore xz is equal to xy is equal to uh, z xy is equal to 50 over square root of 2. And then like earlier, this will lead us to 25 square root of 2. Oops. So area xyz is equal to 1/2 25 square root of 2. Like earlier, just the base, just the 1/2 BH.
And will give you the same.
It will give you the same answer. This is the same solution. It's
Yeah,
just,
shortcut.
it's just a shortcut. This just to show you
25
how you can use
square
this.
inches.
I square
Really
inches.
means
Square inches. There, almost seamless mending.
by the page. Yes,
Okay.
so square ABCD of side length 10 has a circle inscribed in it.
Then
Up, can you remove the so
the
they can read the problem? Let M be the midpoint of AB. Find the length of the portion of the segment of the segment MC that lies outside the circle.
okay. First of all, let's name that segment. So the segment, the portion of segment MC that lies outside of the circle is this portion, the red portion. Let's name
Point
that
E.
E.
Point E. Point E
Yes,
where
point
where
E.
where the where MC touches or intersects circle
Other than the
circle.
square, other than the point of tangency, one point of tangency of the circle and the square. This point. Other than that. So since M is the midpoint, 10, this is square. AB is equal to BC is equal to CD is equal to AD. So AB is also 10. This is 10. So therefore MB is equal to 5. Similarly, AM is equal to 5. So if you don't notice it, where will it be? Quick construction. Then
So
BC.
we have created
I've I've created the right triangle. Actually, I didn't create it. I just pointed it out
yes,
by
there's a
removing.
triangle here.
There's a right triangle here. So if we want to find the portion of the segment MC, a portion of the segment MC, maybe it will be good to find MC itself. So MC by the Pythagorean theorem is equal to, we are lucky today because so far we don't have the hypotenuse given except the earlier example. 5 squared, 25, 125, 100, 125. This is 5 squared to 5, 25 times 5 square root
So
of
what
that.
is that?
So this is equal to MC.
Yes.
Okay, so if MC is equal to 5 square root of 5, then I will just move this little here. Let's call this point and still looks appropriate. So this is 10, this is 10. So and let n be the midpoint of BC. It's not necessarily we don't want to confuse yet. I'm not defining this n as the point of tangency, another point of tangency between the circle and the square is just the midpoint, so we can accurately define these as 5 and 5. Also,
So here, let me be the mid.
ayan, let n be the midpoint of BC. So, and let x equals CE so we can find it easier. Let x equals CE because I don't want to write CE over and over again. So CN, maybe we will use a little of a trick. So I mean, it looks goofy. Let's write a semi-decent segment of the circle. That's too small. They're good. Semi-decent. Hmm. Just to be tangents. I'll just draw the segment here so it will fit. So there's another theorem. It involves a tangent and a secant or a chord. Doesn't matter. So in this case, MC is part of a secant of the secant line MC. So MC is divided by the circle into two segments, ME and EC. So ME times EC. Oh wait, no, sorry. I meant EC times the whole segment MC. So little and then whole segment.
Use a different color.
Ah yes. Small segment and then the whole segment is equal to this segment squared. So NC is 5. DC is unknown, X. And then 5 MC is found to be 5 square root of 5. Therefore, EC is equal to 25, 5 squared, over 5 square root of 5. So that's 5 over square root of 5. So that's equal to square root of 5. So therefore, CE is equal to the square root of 5.
Okay.
Given triangle ABC is an isosceles triangle. AB is equal to 15, BC is equal to 12. So find this area. AB, this is of course an isosceles triangle, so this must be 15 too. Those are the givens. So the first approach will be the a little more complicated approach. So there's a formula, Heron's formula. Let's say you are in heavy doubt, but then you know all three sides of a triangle. It will be very convenient if you can find this area that way. So it is equal to the square root. I will put the top first. So this is S. I will define what S is later. And the ABC. This is true for an ABC, any ABC, scalene or obtuse, whatever. ABC, let this be A, B, C. So let's say we know both all ABC, then S will be the semi-perimeter or one half of the perimeters. ABC is the perimeter over 2. So that's the semi-perimeter. So S is A plus B over plus C over 2. Yes. So this can be proven a multitude of ways, one involving the cosine law. So here, the semi-perimeter is equal to 15 plus 15 plus 12 over 2. So this is 42 over 2. This is 21. So, straightforward,
Substituting.
ABC is equal to the square root of 21 times 21 minus 15, 15, 21 minus 15, oops, and 21 minus 12. Uh-huh. Actually, you don't need to. Wait. Square root of 21 times 6 times 6 times 9. Oh, maybe I need the calculator. So the 6 will be immediately factored out because there are two of them. So then it just was 21 times 9. Square root of 21 times 9 is 21 times 9. 21 times 9 is 189. Never mind. So the square root of 21 times 9 is equal to 3 times 21. 3 square root of 21. So this is 18 square root of 21. No, this is not, yes. There's also another method, it's a more basic method. Let's use, so we have an isosceles triangle. If we draw an altitude is the if you draw an altitude from the vertex in which the equal sides intersect this vertex, then the altitude produced will be a perpendicular bisector. So these will be equal. Yes. So applying that, we have triangle ABC. We have equal sides 15 and 15. Then if we draw an altitude, this is 12. This will be 6. This will be 6. Okay. So again, there's a secret right triangle hiding. 6, 15. This is right triangle. So this is the altitude. Let's call this h. By the Pythagorean theorem again, square root of 15 squared minus 6 squared is equal to...
So yeah, that is equal to what are you looking for?
Oh, I'm looking for h. This is h. So h is equal to... calculator. 3 square root of 21. So there's already a there's already a square root of 21. That's promising. And then, of course, oops, I lost this.
Just here. You can use this one.
Ah, okay.
So we have a space.
This is the altitude, and then the height is 3 square root of 21.
Equal to h.
So 1 half BH, 1 half B times
What's
height
that?
is the area pala. Okay.
Formula for the area of the triangle is
1 half
base
base.
times the height. Yep, put BH first.
So 6 times 3 square root of 21 is equal to 18 square root of 21.
Yes, we get the same. Yes, nice.
Yes.
That's all, folks. Thanks for
Thanks for
watching.
watching.